Okay, so we're going to quickly go through this click of it if you've not yet checked on our videos in the YouTube channel. Okay, so CD, Flipper, and we named the main parts of our smart contract, the storage, our constructor, and we are going to have it more today. We are going to dive deeper into this smart contract. So, and to test this smart contract, we use a cargo test. So, this is going to test our smart contract. So, intro code. Okay, Telegram. Uh, slash is intro code. All right. So, uh, when you're testing the smart contract, it takes quite some short time and while building the smart contract. But as soon as we build these, we are going to be using this and taking it a bit further. So can be patient with it. Um, so today we're going to be covering deep into exploring smart contracts. So we're here, cargo test. We're waiting for the result and then go to compile a smart contract. You can continue to read about the different parts of the smart contract, uh, the hash storage. So smart contract must always have some parts like the storage, the constructor, the storage. They must have the accessible functions. They are mostly under the implement, and they have a pub keyword to make them public to the user. So things like that. Then we should have test. We should be able to be tested. Yeah, we have finished our compilation, and as the results come out, everything is okay. So if you want to build a smart contract, this is in the compile. It's cargo contract build. So this is the command. I love writing these commands because now I get to know them better. That this is what I'm doing. So, but you can copy the command as well. This takes quite also some time. So, but yes, meanwhile we can be looking through the different parts of the smart contract, basics or contract template. So we changed into a smart contract, cargo contract build. So when you look, these are some of the parts of our contract, a smart contract, the one we have also this. So template contains scaffold code that provides a starting point for writing an ink contract. In the following, we'll take a look at what the files contain. The files you get are locally similar, just as we can see. So in our contract here, we have a flipper and version. Authors, you can put your name and your email. Could be the central code, maybe info at decentralcode.com. Sedition and things, we should have the version 4.0. So these are like the initial configuration of the cargo.toml file. And we are going also, so these are embedded in our files as we create a contract. When you say cargo contract new and then the contract name, this is what you get. Now, if you, let me check. So if you build your smart contract in an already built smart contract, you get an error. Let me say now for this one, I'm building, after building, then I rebuild maybe when I'm showing someone, it will of course show me an error because the target files are already there. So then we have the lib.rs. So when we build a new smart contract, we have the cargo.toml and the lib.rs. This is where we put our logic. Every ink contract is required to contain exactly one ink storage struct, exactly one, at least one ink constructor function. Can find two, but for the storage struct, it's exactly one and at least one ink message function. So all these are found in the lib.rs. That's why it's good to explore the docs and also explore your smart contract. The scaffolded code will look similar to the following. We've changed the comments though to explain what's going on there on a high level. So we have this. We are going to look at this file. Actually, we looked at it yesterday, but we are going to look at it now today more in detail. So in case our contract completes building. Okay, still building. If the STD feature from the cargo terminal is something we will switch on, no STD here. This has been the effect of Rust. It's not enabled. So if the feature is not enabled, we switch on no STD. This has been the feature. So this thing has SCFG attribute that is always on the top of the smart contract is responsible for that. Standard is OS dependent and WASM is architecture independent. Okay. So yeah, this is how we start our smart contract. You must have the hash ink contract uh, module attribute up there to make sure that this this file is identified as an ink smart contract file. Yes. So pub mode flipper. This is starting it, and then we should have only one storage, hash ink storage struct. So pub struct flipper. Then this is where we, of course, name our variables. We have, so we shall have uh, a boolean value. The implementation. So we have a constructor here, include capital flipper. So since our smart contract is called flipper, you can have such struct. So in the constructor, that's where you initialize your variables. You can have more than one. You can have more than one constructor, but you should have at least one. Okay, we have another constructor here, and yeah, so that is it. So hash ink message. This is where the public functions are found. So the pub fn flip is one of the public function that we shall have. So it takes in a mutable variable self and does something with it. So we also have pub fn get. So also the get function is one of the functions that is accessible to the user or that is read outside when you deploy a smart contract. So it's under the message variable. Then we can go on to testing. So this is how our file can easily be broken down. And so when you look Wasm optimized, so our smart contract compiled successfully. One of the issues actually I had yesterday is that I had my files updated, but I had not restarted my machine for some time. So that solved the issue, and now we can deploy. Okay. So we've been having a view of what entails in a smart contract. So compile, we have finished compiling. So run a substrate node. So since we are going to be deploying on the UI, so we must start, and this is the command. So when you're starting the substrate node, is a simple substrate which is configured after installing the substrate contracts node. So you must make sure that you have substrate contracts node installed. As we said yesterday, you can click on this link. You need these and be found in the links, or you can just search for documentation online. And then, so I'm going to go to the folder where you have a substrate contracts node and then start it. So that will require me to have a new terminal. Control Alt T. You can also just go here and right click and then have your new terminal opened up. So with this new terminal, I want it to be a bit small as well. So I need to go into my documents and into Polkadot and into Ink. Okay, so when I have this substrate contracts node Linux. So substrate contracts node, and this file I just downloaded it. You can download it when you follow those instructions we've seen. And then we are going to start it with substrate contracts node. So that's the command for starting it. Substrate. Before we start it, if I open the contracts UI, so let me say I open up my contracts UI here. So by default, the local node does not show anything because I haven't started my local development environment. I haven't started a node that is running local on my machine. Yeah, so let me start it. Substrate contracts node. It starts up. So when it starts up, now if I go back to this, can again clean it, but I'm going to just add the smart contract that I've built. So add new, you upload. I'm going to take Alice's account and go to where we have Ink. Today is day 2. Oh no, downloads. It's not in downloads. It's in documents. Polkadot, and then Ink, and day 2 in Flipper yesterday. So I don't know why the Flipper.contract contract code plus metadata. The contract was built in bug. Your contract artifacts are ready. You can find them in A2, Flipper, Target, Ink. I think that is it. Yeah, this could be because of the art contracts that are already uploaded. but that's the idea. I need to invalidate the cache, which will take some time, but that is it. So that's how you compile and then you upload here, and then you can interact like any with any other contract where you access those two methods. One contract not found. Okay, so let me I try to and let me try Bob. Um, New contract upload count Bob. Hey, okay. Flipper. It must be dot contract. So I don't know why this is coming. Let me try to upload documents. Polkadot. Ink. Can go into Flipper here and target ink. So this doesn't have flip. Ink. Flipper 2. Target ink. Flipper 2 dot contract. So yeah, it's the valid bundle. Have to check which reason that comes for. So when I click on next, you can deploy this next, and then of course when you deploy, Bob will have to sign, and yeah, he has signed the document. So the two methods that users can work with is get. So when you get initially when you get the value, it's false, and then we have the result. We can write to the contract, and that will need Bob to sign again, as we see in the top right corner. And then if we call the exposed get method, so these are and the value of the return variables has shifted to true. Okay, so if we go back to our node, and then this is our node, and then we stop it. Let me remove this so that our node is visible. So if I stop it by pressing Ctrl C, and I go back to this, immediately you see that we are no longer connected. So we have finished the recap for yesterday. Today we are going to look at a method of deploying your smart contract using the CLI, using the contract CLI. Okay, so and yeah, we are going to start from there. So we have prepare your first smart contract before you begin. Have good internet. This is a very big requirement. I sometimes got issues because of having a low internet. So you have a fast internet, generally familiar with blockchain and smart contracts. You have installed Rust and set up your development environment. So also you can read through this. This is a substrate document, and let me put it in the description. Um, so update your Rust environment. For this tutorial, you need to. So these are the requirements that you need to really make sure that you have working with your, yes, with your environment. And with that, we can then start. So open the terminal, update your Rust environment. This I've done most of this because this takes some good time. And info component, then install the cargo contract CLI. I have this installed. As long as you press cargo contract version, contract version, and this returns the contract version. That means that you successfully installed your cargo contract CLI. So install the latest version of cargo contract. Okay, help. Yeah, install the substrate contracts node. So for this, we are going to install the substrate contracts node as well using this command. Now this command makes sure that whenever in whatever place you call your cargo contracts node, you can, like, you can initialize it. So wherever you call your node from, you can initialize it. Whereas with the other, we had downloaded our node and we always start from yes, from the location of our contracts node. So that I've also downloaded. Now create a new smart contract, and we are going to use this same smart contract flipper, the CDLSL. Okay. Um, I think yes. So we are in flipper. So ls page ls-al. So yes, it looks like we are on the same page. Everything is smooth. So like other Rust projects, the cargo file, cargo.toml, explorer. So now this is the time we can explore our file. But as already we have already explored it, so I'm going to open it in VX Code, Visual Studio Code, VS Code. And as it's opening, we can continue. So test the default contract. So to test, open terminal shell on your computer if needed. Verify that you're in the Flipper project. Use the test sub command. So cargo test. Now we've gone through that, but we can go through it again. This time in our it seems there are some things like fetching metadata. Terminal to complete and shall run the output similar to the following to indicate successful test completion. So build the contract. After testing the default contract, you are ready to. So we have tested. Can give them some time as we continue. So and then we shall start and run cargo test writing these commands. So let me start a new terminal. I think I can close this for now. Say Control Alt T, one new terminal. Just cd into just documents. So wherever you start yours, if you follow the other steps, wherever you start uh, your terminal from works. So can take on um, substrate contracts node dash dash log info. So here now we are starting using the CLI. So here there is no space info between info and runtime. It's just a comma and double colon contracts debug. I can extend this here. So 2 is greater than 1. So okay. So with this, we've started our node, our local node, and it's running. Um, Maybe I can increase this a bit further so that we can see many things. Okay, so this is it. There's a lot of information. Local node identity is this. Okay, so we have started our node and it's time to go. Okay, deploy the contract. So we are going now to deploy the contract. So when we're deploying the contract, we upload the instance of the contract and then initialize. Yeah, start your node using Substrate, which we have done. Go to the Flipper project, build a contract using cargo contract build, which we have finished to do. Upload the contract. I love typing this because initiating, because we have already built contract instantiate new your your instantiate call has not been executed. To submit the transaction and execute the call in chain, add dash x execute flag to the command. So if you want to, yeah, this is a very good thing. You can also find more commands when you say cargo contracts help. It is contract. So this will give you very many other commands and code check and most things. But here we have uploaded a smart contract, and this is the contract and put and continue. So dash dash contract contract address dash dash get, and then sorry Alice. So you can dry run. A dry run is also optional. Called specified. So wait of this storage contract was found that the specified contract is invalid. We can try to meanwhile We're almost there. So our test are successfully run. Now for the build, so cargo is still checking. Can I go also go for the cargo contract build? As that is building, we can explore the files here in the lib.rs. So okay, um, This takes some small time. Hopefully, so after building this, then we can quickly start working on this. So since we are going to be working on an incremental smart contract, we shall have to have a number that increment and call it my number of type RU32, so that we can also initialize it. So we'll go to our storage. um, Probably let me export some account ID. This will be the ID of the person incrementing. And then at commenting and documenting, I can say this is my balance. My balance is of type. So these account ID and my balance built into Ink. And also read about them and storage. So, uh, um, then storing variables. Now that you have some status source code for the incrementer smart contract, you can simple values. The following code section is intended to illustrate. So our incremental constructor, initial value self value init value. So we must make sure that the value is I32 and not bool. So value I, so we don't have a value. Add a second constructor function named default. In here we have value set to 0. So we have the semicolon, because this is a return type. Okay, save your changes and close the file. Try running the test subcommand again, and you will see that the tests are now failing. This is because we need to update the get function and modify the tests. So if I save, okay, cargo check. I already have errors because we need to update this get function. So for me, I cannot even test or show the errors. So add a function to get a storage value. Now that you have created and initialized a storage value, you can interact with it using public and private functions. For this tutorial, you add a public function as known as message. So always public functions are under the hash message attribute to get a storage value. Note that all public functions must use the hash ink message, yes, attribute macro to add the public function to the smart contract. Open lib.rs, update the get function to return the data for the value storage item that has the I32. So here we are going to return I32, and instead of bool, shall always return I32 because it is no longer boolean. Okay, and we must also have the logic to increment. So value, we've talked about it. Replace that test your contract comment in the private default works function with code to set the get function. So in the works, we are going to, so after getting this, when we go in our tests, default works, let increment default assert equal can be anything. So this is incrementer. Perfect. Yeah. So that this is an asset. So we have named this an incrementer, and Yes, we have solved. So we are going to go to the next check. So it's like we are looking whether the default value works. So as long as it can get a value from this position, then that value works. Then that assertion works. Function. Yeah, we're not returning anything. So that means we shall have a semicolon at the end and of that value. So I'll add that. Can get this. The I32 shall add it um, to the value so that we keep incrementing. So add a new test, of course. So add a new test to the source code to verify this function. So our test it works. Let mute incrementer 42. So let's take if let mute incrementer equals incrementer new. This is no longer boolean. Give it 40 or 42 for this sake, and assert equal contract dot get. So that means that we shall get that value. Okay, incrementer dot get. We shall get the value 42. If it was a 0, we shall get 0. Then after incrementing, so incrementer dot ink 5. Ink is a public function, so if on the 42 we add on 5, what should our assertion be? So assert equal incrementer dot get should be 47. So and, yeah, so we have contract dot ink still not contract. For our case it is incrementer because that's what I've named this. uh, so if I increase by negative 50, it means that all the get function have negative 3. I think those assertions are enough. Okay, save the file cargo test to run the cargo test. So if the test passes, that means that okay, we have passed and the tests are passing. So, yeah, so there we can probably build the WASM by cargo contract build and then deploy. Cargo contract build, and this has to take some Not compile. Due to one previous error. Self.value arithmetic operation that can potentially result in unexpected side effects. So, okay. So mute self by I32 self.value plus equals. So self.value plus equals has some issues. Then plus by will give me by that can cargo contract build. So I think here shall have to rectify it. But that's how we build the smart contract, and you can add new tests, build the WebAssembly, and deploy. We have added the two tests. So this is the command to deploy to the local node. We have to restart it, or we can even upload the instance to working using contract UI. And yes, so this is it for today. It's a good experience, so you can go through it, finish it. Here we have use maps, build an ERC20 token, cool stuff, and troubleshooting smart contracts. Let me call it a time. Great to have you here, Cox, and everyone else who is in. Yes, we meet next time. Bye bye.